Why isn't it recording? Okay, there we go. It is. Yay. Okay. So our first lesson is on angles, arc length, and circular motion. All right, so let's take a look at vocabulary words. So this is just vocabulary words. We have standard position. Standard position has some criteria. So its initial side has to be along the positive x-axis. So let's start drawing one. So this is initial side. Initial. Our vertex has to be at the origin, and the terminal side can be in any quadrant or quadrantal. Okay, we're going to just do this one. This is the terminal side. So initial, terminal. This particular angle is in standard position. When it talks about the terminal side, so this piece right here is a terminal side, and let's just make it a different color. So this is a terminal side. So terminal side. The terminal side can be in any quadrant or quadrantal. So quadrantal just means the x or y axis. That's all a quadrantal is. It's a fancy word for saying x or y axis. We're just doing vocabulary right now. Okay? Counterclockwise is a positive direction, so this, since I'm going counterclockwise, this would be positive. This is a positive direction. If I went backwards, that would be a negative direction. So positive is counterclockwise, clockwise is negative. That's just the what we do. This is what we do. So let's draw some angles. Let's sketch some angles in standard position. So we have 600 degrees. Okay, yes, I can do calculus in my sleep. No, I cannot like add and subtract, but that's okay. I'll just write it down. So let's see. That's what, 240. So basically it's one full rotation around and then an extra 240 degrees. If you recall, this would be like 90 degrees. That's like 180 degrees. That's 270 degrees. So we're going to go, and I'm going to change the color so we can, distinguish what's going on. So we went all the way around one time, and then now we're going to go 240 more degrees. So that would put us, somewhere right here. So we would label that 600 degrees, and that is drawing or sketching the angle in standard position. You might see some pictures like that on your online homework. They might ask you if the angle's in standard position or which one is the right one. So that's what we're talking about. One more. So let's work with radians. Yay. So if you recall, that was 0 radians. This is pi over 2 radians. This is pi radians. This is 3 pi over 2 radians. But this one is negative, so we're going backwards. So I've got to rotate backwards. Now, if we're thinking about negative, and let me just change the color. If we're going this way, this would be like negative pi over 2, right? And if we're going negative, that would be negative pi. And that would be, what, negative 3 pi over 2. That's if we were going negative. You don't have to write all that. I just want to make sure we completely understand what's going on. So if I want to draw an angle, a negative pi over 5, I think about, okay, well, I've got between 0 and negative pi over 2, a half of a pi. Well, a fifth of a pi is smaller, right? So my angle is actually going to be like down here somewhere. And I would, show the rotation is backwards and just label it negative pi over 5. And that's angles in standard position. Are we okay with that? Yes? Okay, great. All right, let's go to the second part up here, which is converting from radians to degrees or degrees to radians. We did this last year, you may recall. We just have to decide which of the conversions do we need to do. Do we need to do pi over 180 over pi or pi over 180? Just recall, if you have a radian, right, if you're going from radians, these already have a pi in them, right? And we want to get rid of the pi. So that's why it makes sense that we would multiply by pi 180 over pi, so the pi's would cancel out, right? That makes sense. On a reverse, if we have degrees, this is in, degrees, we would want to get rid of the degrees and insert a pi, right? So hopefully it shouldn't be hard to figure out which one to use. Typically, it's whether you gain a pi or lose a pi is really what you would think about. So now let's do some conversions. Now, I'm not expecting you to do a bunch of numbers like in your head or whatever. If we have some serious computations, you'll be able to use your calculator. Here we want to convert from degree to radian or radian to degree. Okay, great. So here I have a degree, which means I need pi. So I'm going to multiply by 180 over pi. And that's going to be 45 pi over 180. We would really want to simplify that. So I'm going to get my calculator. And I'm just going to put that in. So it's a fraction is control division. So what was that? Was that 45 over, was it 180? Is that right, ladies? Okay, perfect. And so then we just hit enter and it simplifies it for us. That should have been reduced to 1/4. So let's go here. So we've got, basically this turns into pi over 4, 1 pi over 4. Okay. The next one, it's in degrees. So we want to go to radians. So again, we're going to multiply by pi over 180, which gives me 57 pi over 180. So again, I really, don't want to do that in my head, and I know you probably don't either. So let's go here. So that would be, what was it, 57? Because it seems to me that shouldn't really simplify, right? 57 is a bit messed up. I mean, I don't know, but it actually does. So it's 19 over 60. So 19/60ths. All right, so this turns into 19 pi over 60. And yeah, we will be using our calculator somewhat on this lesson, so it's fine if you have it out, you want to use it, or if you don't want to get it out, it's fine. I will do the calculator for us. All right, the next one is definitely a radian. See how it has a pi in it and no degree sign? Okay, great. So we know to convert it, we want to multiply by 180 over pi. So that's what, negative 360 pi, oops, pi's cancel out over 3, and that's a degree. So let's, now I think I could do that in my head, right? That was at negative 120 degrees. Okay, so great. Making progress. Number 6 is a bit tricky. It doesn't look like a radian. There's no pi, but it actually is a radian because there's no degree symbol. That's what is really important for us to recognize, is that if we forget to put the degree symbol, then basically you're telling me that it's a radian. Okay, so just be aware, this really is radian because there's no degree. So I want to multiply by 180 over pi. And since I have a decimal in here already, I just want to multiply it all out into a decimal form. I don't really want to, keep the pi in there. So when I put this in my calculator, and I'll just trust me that I put it in there, it goes to 35.523, and now we're in degrees. Okay, and that's conversions. That should be, we're just really reviewing, right? There shouldn't be anything new yet. Are we okay? Okay, on the next slide, the last slide for today, there probably is a few new things, but they're not bad. I do need to talk about formulas. So in my goal to prepare you for whichever calculus you choose to go to, whether it's here or at college or whatever you want to do, it's pre-calculus, right? It's pre-calculus. You're actually going to have to memorize formulas. So if you think about, let's say you think about your English class, has your English teacher ever asked you to memorize vocabulary words? That's like a thing, right? That's what you do in English, right? Because you have to memorize words or you don't know how to read them, right? Or what they mean. Same thing with math. We have things we have to know. I mean, unfortunately, we just have to memorize. And if you are going into A, B, or BC, you're not going to get a formula chart, so you need to work on memorizing things. So this is a formula you're going to have to memorize if you want to use it. If I were you and I were sitting where you are, I would highlight it and maybe, consider making a flashcard. I would consider making a flashcard. That's what a lot of students do when they get to calculus, is they make flashcards. If you start now, then you're already ready, ready. You're getting yourself ready. So that's what I would consider doing if I were you. All right. Or maybe y'all have used Quizlet before, where you can do, maybe you want to write a Quizlet and put stuff in there, or maybe you want to write one and share it with me and I share it with everybody. I mean, I don't know, whatever you want to do, right? Just whatever will help you to remember these certain formulas. So let's look at this formula. It's arc length. They denote arc length as an S, which seems strange to me, but that's just the letter they like to use. That just means arc length. R is radius. And the key here is theta, which I think we're used to seeing a theta. It has to be in radians, or this formula does not work. It has to be in radians, okay? Fairly simple formula, S equals R theta, but the trick is remembering, well, to remember is one. The second is to know that theta has to be in radians. Okay, so that's one. Let's look at our second formula. We're looking at area of a sector, and these are Precal formulas. You did things like this in geometry, but you use like percents and ratios and all different kind of things. We're not doing that in Precal. We're just using the Precal formulas. So here, another formula to put on your memory list. So this is area of a sector. It's pi r squared theta, and again, probably no surprise, theta has to be in radians. Okay. So we're going to practice using both of those formulas with these three examples down here. Okay, so let's go to example number 7. Here we want to find the radian measure of the central angle of a circle of radius r that intercepts an arc. Okay, this is a fancy word. Let me show you what it means. Okay, so what they're talking about is, why can't I be okay with it not being perfectly straight? I don't know, I can't. I just can't. Okay, see how those lines extend out from the circle? That's what it means by intercepted, the arc intercepted. So this is the arc right here. This is the arc, and they've actually given us the arc length of 150 kilometers. I'm not going to put the units with it when I'm drawing it on the diagram. You can if you want. So that's my arc length, and then the radius of this particular circle, this is 80 kilometers. Okay, what do they want us to find? They want us to find the central angle. Okay, so the first thing that I would do is I would write down my formula, because I've memorized it, right? I write down my formula, S equals R theta. And then I just figure out what numbers I have and what I need. So I have the arc length, which is 150. I have the radius, which is 80, and I don't have the theta. Well, that's not too bad. I just need to solve for theta. So theta is going to be 150 over 80. And so what is that? So the zeros go away. So it's, 15 over 8. Now, you don't have to put RAD, but some students get really upset that you don't write anything there. So you can put RAD, but if you don't put anything, it means it's a radian, right? You do not have to put RAD, but you can if you want to. All right, and I need to scoot all this guy over. Okay, isn't that great how you can move stuff around? I've become so spoiled that when I try to write on paper, it's like disappointing because I can't move it. What's wrong? I've just been spoiled, completely spoiled. All right, so number 8 is the most challenging one. Yay! So we're going to skip that for right now, and we're going to go to we're going to do number 9. So we've got a sprinkler on a lawn is set to spray water over a distance of 70 feet. Okay, so here's the sprinkler. I have to draw stuff. I can't just do stuff in my head. It's not possible for me. Okay, sprinkler, just 70 feet. Okay, so that's 70 feet. But we know when a sprinkler goes, it just makes an arc, right? So the radius is 70 feet. It rotates through an angle of 120 degrees. Find the area. Okay, so they want us to find the area of that lawn that's watered. Okay, that might be helpful. So let's write down our formula. A equals, which we've memorized, right? 1/2 r squared theta. Okay, that's good. So 1/2 r squared theta. Let's see what we have. So we've got, well, 1/2. Radius, we got that, 70 squared. Now, we've got theta, but is it in the right mode? No. So I'm just going to tack on the end right here, the conversion, because I'm just going to stick all this in my calculator at once. There's no sense in fixing things one thing at a time. So 120, let's see, what is our conversion factor? It's what, pi over 180, because we want to get into radians. So I'm not going to pull the calculator up to show you, but you would just type all that in just like that. And that's going to give you that the area of your lawn that you're watering is going to be 5131.268 and its area, so feet squared. All right. Not too bad, right? So all we need is the formula. If you don't know the formula, are you going to be able to do this problem? No, it will be very frustrating, right? You wouldn't know what to do. But if you know the formula, you just write it down and you find the numbers that you need. That's all. So formulas are critical for us. Now let's get to the super exciting one. Okay, so we have Beijing. So Beijing, China is due north of Perth, Australia. The latitude is 39 degrees. Oh, look at this new notation. You're probably like, yay, I want to learn something new. 39 degrees, 55 minutes north. In means in the northern hemisphere. The latitude of Perth is 31 degrees, 58 minutes south. How far apart? First, before I start in this, I want to clarify that 60 minutes, this is the notation for minutes, but I'm going to write 60 minutes is equal to 1 degree. That's the conversion between minutes and degrees. 60 minutes are in 1 degree. Okay. On Wednesday, we're going to learn more about DMS, degrees, minutes, seconds. That's a system, you know, you might see that in latitude. It's something good to know. This is an intro to it. We're just introing it. All right, so let's, how far apart are the two cities? Okay, so we need to draw the Earth. Oh gosh. Okay. No, that's gonna, so this is my rendition of the Earth. Here's the center. This is the equator. Sorry, it's not perfect, but you got what I'm saying. This is the equator. Okay. So the northern hemisphere is on top, and Beijing is here. So we're going to, this is, let me make it a little bigger. Beijing, and the way latitude works is it's an angle measure. So this angle measure is 39 degrees and 55 minutes. Okay, that's what that angle measure is. Now let's go to Australia. So here's Perth. And that angle measure is 31 degrees, 58 minutes. Okay, we want to know how far apart they are, but it's not a straight line distance, is it? That's an arc length. We want to know, this is what we want to know. What is this? What is that? So let's think about our formula. Arc length equals r theta. So the radius that we're going to use for the Earth, what we like to use is, so radius is going to be 3,963 miles. That some textbooks like to round that to 4,000, and it'll tell you in the instructions if you're going to round. But that's how the radius of the Earth, 3,963 miles. So we got the r, great. So let's shrink it a little bit. So that's gonna, the arc length is going to be 3,963 miles. Now it wants to know the angle measure. I have two different angle measures, but I want that whole sector. So what do you think I'm going to have to do to those two different angle measures? Add them. I'm going to have to add them together. So let's do some, some scratch work over here. 39 degrees, 55 minutes plus 31 degrees, 58 minutes. So when you do this, you just add minutes to minutes and degrees to degrees. You don't cross over. So 5 plus 8, 8, 9, 10, 11, 12, 13. So it's 113 minutes. Now let's add the degrees up. Let's see, 9 plus 1 is 10. So what is that? 70. So 70 degrees and 113 minutes. Now that doesn't seem proper, does it? Didn't we say that 60 minutes was a degree? Right? So what should we do? We should take out 60 of the 113, right, and move it over to degrees. So let's just rewrite it so it's in proper form. So this would actually be, in proper form, 71 degrees, and 113 minus 60 is 53 minutes. That is my angle measure. So we're going to write 71 degrees, 53 minutes. But is it okay to leave it like that? Can we leave our, no, we cannot leave it in degrees. We have to convert it to radians. Why don't we just put it all together in one lump? And that would be what we need, pi over 180, right? Okay, now I'm going to take you to the calculator for this one. Does everybody have that down? Okay, so we want 3963 times 71 degrees, 53 minutes times pi over 180. All right, so let me go to my calculator. And let's type in the 3963 times, I'm going to go ahead and put the fraction next because that's easier. So control equals, so we need pi over 180 times. Now there is a button on here for degrees, minutes, seconds, but I don't remember where it is. So just, I'm going to show you how to do it without the button. We can look for the button later. But the way to do it without the button would be to put 71 plus, we want a fraction, and how many, was 53, and how many minutes are in a degree? 60. So basically, this gives me the number that I want. You know, it's 71 degrees plus a little bit, right? A part of a degree, which is 53 minutes, so 53 over 60. And this is going to give me what I want, all right? But again, there is a code. I just don't remember where it is. So then I'm going to hit Control Enter so that I get a decimal equivalent or approximation. So these two cities are 4,971.983 miles apart. And remember, we're always going to go to the thousands unless indicated otherwise. All right, so this is how we would put this on our calculator. And of course, it's in the recording. As long as the recording is working, we'll see. And so let's go back to our document. And so they are, 4,971.983 miles apart. All right. Let me stop the recording.